Now, let's move to the next idea, the tangent line. Earlier, we talked about the secant line, which connects 2 points on a curve. Now imagine what happens if the second point gets closer and closer to the first point. As x approaches A, the secant line approaches the tangent line. So the tangent line is the line that just touches the curve at one point and shows the slope of the curve at that point. Mathematically, we define the slope of the tangent line using a limit. The slope of the tangent line at x equals a is limit as x approaches a of f of x minus f of a all over x minus a. This expression looks very similar to the slope of the secant line. The only difference is that now we are taking the limit as x approaches a. That means the second point on the curve moves closer and closer to the first point. We can also write this limit in another form. Instead of using x, we use h. Then the formula becomes limit as h approaches 0 of f of a plus h minus f of a all over h. Here, h represents a small change in x. As h approaches 0, the 2 points on the curve get closer and closer together. If this limit exists, it gives the slope of the tangent line at x equals a. This is actually the definition of the derivative. Now, let's look at an example. We're given the function f of x equals square root of x, and we want to find the slope of the tangent line when x equals 4. So first, we need to evaluate the function at x equals 4, which is f of 4. To find f of 4, I will replace x with 4. Square root of 4 is 2. So f of 4 equals 2. So the point on the curve is 4, 2. Next, we use this formula to find the slope of the tangent line at 4. We will replace a with 4. So I have limit as h approaches 0 of f of 4 plus h minus f of 4 all over h. To find f of 4 plus h, we'll use this formula f of x here and replace x with 4 plus h. So f of 4 plus h is square root of 4 plus h minus f of 4 was found in step 1, which is 2. So we are going to replace f of 4 with 2 all over h. So we have limit as h approaches 0 of square root of 4 plus h minus 2 all over h. First, we'll check to see what happens if we plug in 0. If I plug in h equals 0, I have square root of 4 plus 0, which is square root of 4, which is 2, and 2 minus 2 is 0. If I plug in h equals 0 here, I have 0 in the denominator, which is 0 over 0. This is an indeterminate form, so we cannot evaluate the limit directly. We need to use algebra to simplify the expression. When we see a square root like this, a common trick is multiplying by the conjugate. The conjugate of square root of 4 plus h minus 2 is square root of 4 plus h plus 2. So we multiply the numerator by the conjugate and the denominator by the conjugate. This does not change the value because we're multiplying by 1. In the numerator, I have square root of 4 plus h minus 2 times square root of 4 plus h plus 2. This is a factor of the difference of squares. A minus b times a plus b is a squared minus b squared. So I have square root of 4 plus h squared minus 2 squared. And in the denominator, I'll just take h times square root of 4 plus h plus 2. From here, we need to simplify the numerator. Square root and the square canceled out. So in the numerator, I have 4 plus h minus 2 squared. And 2 squared is 4. And we'll leave the denominator the same. 4 minus 4 is 0. So I only have h left in my numerator. And we cancel the h. So we have 1 over square root of 4 plus h plus 2. Now, we can safely plug in h equals 0. Notice that I keep the limit notation the whole time until I substitute h equals 0 at the very end. This is something we should always do. Now, evaluate this expression. 4 plus 0 is 4. Square root of 4 is 2. 2 plus 2 is 4. So I have 1 over 4. The slope of the tangent line to the graph of f of x equals square root of x at x equals 4 is 1 over 4. Now, let's find the equation of the tangent line. From part A, we already found that the slope of the tangent line is 1/4. We also know the point on the curve when x equals 4, which is 4, 2. Now, we use the point slope form of the line. The point slope form of the line is y minus y1 equals m times x minus x1. M is the slope of the line, which is 1/4. x1, y1 is a point on the line. In this case, we have 4, 2. So we can substitute m with 1/4, x1 with 4, and y1 with 2. And this is the equation of the tangent line of the function f of x equals 4. If we want, we could also rewrite it in the slope-intercept form, but this form is already perfectly fine.